My name is Chaitanya Krishna. I'm from section ITA. My roll number is 19. My topic is NAND flash memory, challenges and opportunities. NAND flash memory is a type of non-volatile storage technology that does not require power to retain data. An important goal of NAND flash development has been to reduce the cost per bit and to increase maximum chip capacity so that memory can compete with the magnetic storage devices such as hard disks. NAND flash has found a market in devices to which large files are frequently uploaded and replaced. In MP3 players, digital cameras, and USB flash drives use NAND technology. Flash memory technologies have provided enormous benefits to modern electronic devices, but non-volatile memory cards in cameras to enterprise-class SSDs, but despite the benefits, flash technologies such as NAND flash present several key limitations and challenges that include performance, reliability, including wear, erasure, and sensitivity. NAND flash saves data as blocks and relies on electric circuits to store data. When power is detached from NAND, When power is detached from NAND flash memory, a metal oxide semiconductor will provide an extra charge to the memory cell, keeping the data. The metal oxide semiconductor typically used is a floating gate transistor (FGT). These FGTs are structured similar to NAND logic gates. NAND memory cells are made with two types of gates, control and floating gates. Both gates will help control the flow of data. To program one cell, a voltage charge is sent to the control gate. NAND flash memory operation. Flash memory is a special type of electronically erasable programmable read-only memory (EEPROM) chip. The flash circuit creates a grid of columns and rows. Each intersection of the grid holds two transistors separated by a thin oxide layer. One transistor is called a floating gate and the other is called the control gate. The control gate connects the floating gate to its respective row in the grid. As long as the control gate provides this link, the memory cell has a digit value of 1, which means the bit is erased. To change the cell to a digital value of 0, effectively to program the bit, a process called Fowler-Nordheim tunneling or simply tunneling must take place. Tunneling changes the way that electrons are placed in the floating gate. A signal voltage is set along the respective column line of the grid, enters the floating gate and drains the charge on the floating gate to the ground. This charges causes electrons to be pushed across the oxide layer and alters the charge on the oxide layer, which creates a barrier between the floating and control gates. As this change drops the charge between a certain threshold voltage, the cell's value becomes a digital 0. A flash cell can be erased, returned to digital 1 by applying a higher voltage charge, which stops the tunneling and returns a charge to its floating gate. This process requires voltage provided by active control circuitry, but the cells that compose the flash device will retain their charge or drain states indefinitely once external power to the chip is removed. This is what makes NAND flash memory non-volatile. The process of charging and tunneling that takes place in a flash cell are destructive to the transistors, and the cell can only be programmed and erased a finite number of times before the cell starts to break down and fail. It's a flash concept called memory wear or just wear. Types of NAND storage. Common types include SLC, MLC, TLC, QLC, and 3D NAND. What separates each type is the number of bits per cell. The more bits stored in each cell, the less expensive the NAND flash storage would cost. SLC or single level cells store 1 bit per cell, and SLC has the highest endurance, but it is also the most expensive type of NAND flash storage. MLC or multi-level cell stores 2 bits per cell because erasure and write cycles occur 2 times more. MLC has less endurance compared to SLC, however it is less expensive. Many PCs will use MLC. TLC or triple level cells store 3 bits per cell. Many consumer level products will use this because it is less expensive, however lower performing. QLC or quad level cells store 4 bits per cell. QLCs have even less endurance and are generally less expensive. 3D NAND. 2D or planar NAND has only one layer of memory cells, whereas 3D NAND stacks cells on top of one another. Samsung refers to 3D NAND as vertical NAND or VNAND. NAND shortage. The insistent demands of data storage and portable devices has spawned a shortage of NAND flash chips. The NAND flash shortage began in 2016 and has continued throughout 2021. The shortage is partially the result of demand, but it is also because vendors are transitioning from manufacturing 2D or planar NAND to much denser 3D NAND technology. Making 3D NAND chips is a much more complicated process. Today, solid-state drives, SSDs, which we call, and smartphones are primarily the drivers of the NAND flash market. The NAND flash memory market reached over $46 billion USD by 2020, and it is expected to reach over 85 billion USD by the year 2026. Limitations and challenges of NAND flash memory. Flash memory has a finite number of program erasable PE cycles. Most basic flash products are rated for 1 lakh P by E cycles before the storage cell integrity begins to fade, though some types of NAND flash chips are rated for 1 million programmable erasable cycles or more. Wear is usually mitigated by spreading out write operations across the entire flash device, which is called wear leveling. Write verification and remapping techniques can also be employed to support bad block management. It is worth noting that RAID cycles aren't limited. Although flash memory can be written a byte or word at a time, flash memory must be erased in entire blocks. When a block is erased, all bits are set to 1. Once a bit is changed to 0, that entire block must be erased to change a bit back to 1. It takes finite time to erase a block before new writes can take place, limiting the overall performance of flash memory compared to other forms of volatile memory, such as dynamic RAM, also abbreviated as DRAM. Erasure is also part of memory wear issue. High energy particles, such as X-rays, can sometimes change zeros into ones in an array of flash memory cells. X-ray resistant memory devices are available to help prevent such issues. Thank you.